Okay, today we forge ahead and look at something we call trigonometric identities. So join me in this video. So we are going to also be driving them on how they come. Tan theta is equal to sin theta over cos theta, and for all angles theta, cosine square theta plus sine square theta is equivalent to 1. So how can we drive this? So we are going to derive them together. Alright, so let's consider a unit circle. Alright, so I'm going to draw the coordinates here. So if you consider, all right, a unit circle having y there, having x there, so let me just draw a unit circle for you. So let's consider this as our unit circle. So let's say this is the point of origin. Then of course we have a line from the origin there to the point somewhere there. Let's call that point P with coordinate x comma y, and let's call that the radius, and let's call this one theta. So from here we know that sine theta is equal to what? Opposite, right? That is, if we take this, if we just do this, I'll just do this. Opposite is this side here, which is just what? Y itself, right? Because this side is y and this side is x. So opposite is y over r, and cos theta is adjacent, which is x, over what? Over r. And we know that tan theta is what? Opposite, which is y over what? Over x. Now y over x, right? Exact. Now you'd recall that y over x, all right, is just equal to y over r multiplied by what? R over what? Over x. Do you get it? Do you agree? Because r and r will cancel, eh? Yes, but what is y over r? Y over r is sin theta multiplied by what is r over x? Now we know that x over r is cos theta, right? So if I say r over x, it will be the inverse of this. So I'm going to multiply by the inverse of cos theta. So I'm having y over x is equal to sin theta over cos theta. But what is y over x? Is tan theta. Is tan theta, which is equal to sin theta over cosine theta. So this is the first identity that you need to know. The next identity is the Pythagorean identity. We are also going to consider a unit circle. So now let's go on and prove this one. So we are going to consider a unit circle as well. Everything has been labeled for you and that. So we are going to consider the Pythagorean theorem. Now we are going to consider the radius. We express the radius in terms of x and y. Now from Pythagorean theorem, we know that r squared will be equal to x squared plus what? Y squared. We know this, right? So because this is a triangle, a right angled what? Triangle. So r squared is equal to x squared plus y squared. This is Pythagoras theorem. So Pythagoras theorem. So now if you use if we know that sin theta again is y over r, and cos theta is x over r, right? From here, right? So we can express y as sin theta, as r sin theta when you cross multiply. Even here, we can express x as r cos what? Cos theta. Are we so far good? Now remember this p. Since p lies on the circle, all right, we are going to consider the distance. This is just the distance. If you remember how we used to find the length of a straight line, which is length OP. So going back to the formula here which we got, we are going to get r squared is equal to, what is x? X here is r cos squared plus r here sine squared, like that. So let's now expand this. So we have r squared equal to r squared here, cos squared theta, plus r squared sine squared what? Theta. Let's divide r squared throughout. I'll get 1 there. I'll get cos squared theta. I'll get sine what? Squared theta. Can you see something here? It's cleared there. Alright. So yachoka. So therefore yachoka. Cos squared theta plus sine squared theta is equivalent to what? To 1. We've done this together. It's there. Let us now look at 2 examples. So let us simplify this. So how can we simplify this? So here there's nothing difficult on the first one because we are coming from the equation sine squared theta plus cosine squared theta. We are saying is equivalent to what? To 1. Now theta here should be the same, and when we look at this, they're all having 3 theta. So therefore sine squared 3 theta plus cosine squared 3 theta, this is just equal to 1. You can just replace the theta by 3 theta. It's done. We've simplified it to 1. This one here, where we can just factorize what is common there. So we can take out what is common. So we have 1 here minus sine squared what? Theta. But when we go back to the identity, this identity here, alright, we can make cos theta the subject of the formula. So if I make cos squared theta, sorry, the subject of the formula, I'm getting 1 minus sine squared theta, which I can see here. So I'm just going to replace that with cos squared theta. And my answer is 5 cos squared theta. This other one says show that cos 4 theta minus sine 4 theta over cos squared theta is equivalent to 1 minus tan squared theta. So we are going to get our left hand side because it's a bigger side. So taking the left hand side, so we're going to rewrite this one. Let us first rewrite it. Cos 4 cos to the power 4 theta minus sine to the power 4 theta over cos squared theta. So you might recall that this is just a difference of two squares, right? If I've got 2 squared minus 2 squared, just the difference of 2 squares, which I can just write it as this and as this. I think another difference of 2 squares we did back then. So this is just this I can express it as cos squared, because remember it's a square, right? Theta minus sine squared theta. Then I will repeat the same but with a different sign here, plus, because on top here it's just a difference of 2 squared because there's a minus, over cos squared theta. Now we know from the identity that sine squared theta plus cos squared theta is equivalent to 1. So here where we have this one, just replace 1 there, such that we have cos squared theta minus sine squared theta over cos squared theta, because this is just 1 times this, we get the same, and therefore we can go and divide throughout squared theta over cos squared theta minus sine squared theta over cos squared theta. Why have I branched like this? Because this is a common denominator. I can write it in that way, and this will give me what? 1 minus what is sine. Now because there's a square there, we know that sine theta over cos theta is equal to what? Tan theta. Tan theta. So if there's a square there and a square there, this will also be what? Squared. So this just will be equal to an what? Squared theta. Hence, shown. So for now, we'll just look at those 2. Next time, we are going to look at other identities.